Okay, what we're going to do is we're going to do completing the square today. So first thing I want to do is just show you basically what we've done before and what we're going to be doing now. So what you've seen before is we've gone from vertex form to standard. Okay, remember the reason vertex form is useful is because we know where the vertex is very easily. It's going to be at -4, -7. So in the past, what you guys were asked to do was you would take this quadratic in vertex form and change it into standard, or I'm sorry, standard form. So when we FOIL this, what we end up with is x squared plus 4x plus 4x plus 16 minus 7. After we combine like terms, we end up with x squared plus 8x plus 9. Okay, and again, if you wanted to check and find the vertex of our quadratic that is just written in a different form, it's not changed, it's the same exact line. But if you wanted to find the vertex, remember negative b over 2a, which in this case would be negative 8 over 2 times 1, which is -4. And if you plug in -4 for x, I guarantee you're going to get -7 for y. So again, that's what we've done before. We've already seen that. What we're going to be doing now is we're going to be going from standard form back to vertex form. Okay, so it's a little bit different, not exactly what you're used to, but since we have been able to factor quadratics now we can definitely do this new form here. So what we're going to do is take an equation in standard form. Now, again, what we're going to do is we're going to make this look like vertex form. So okay. First thing we need to do is we're going to change some things. We're going to move some numbers around. So what we're going to do is get rid of 4. We're going to subtract 4 to both sides. Again, we can do this because rules of algebra. We haven't changed anything. We're just moving some numbers around for a minute. So on the left side, we have y minus 4 is equal to x squared minus 10x. And now we have something that looks like it's getting closer to vertex form. Okay. The next step is pretty key. What we're going to do is we're going to add b divided by 2, the quantity squared. So in this case, b is -10. So if we have -10 divided by 2 and square it, what we get is -5 squared, which is equal to 25. So this is a pretty key step. Okay, we're going to add that to both sides. That way we're not changing anything, we're not changing the value of this equation, where everything's going to work out at the end. So if we add 25 to both sides, our new equation looks like y plus 21 is equal to x squared minus 10x plus 25. Okay. Now, if you look at the expression on the right-hand side, hopefully you guys are recognizing now that that's a perfect square pattern. So what we can do is now factor that. So this is the next key step. Factor. Okay. So what we're going to do is, hopefully you remember what pattern that is. So we have x minus 5, the quantity squared. Okay. Now, again, I'm hoping you guys can see that last step is a layup. We're just going to subtract 21 from both sides. And then our new quadratic looks like x minus 5, the quantity squared, minus 21. Vertex is going to be negative 5, oh, I'm sorry, positive 5, negative 21. Okay, so again, just to double check that, what we'll do is, what I've done is I have graphed it in my calculator just to make sure that you guys realize that we didn't change anything about the equation. All we did was we wrote it in a different way. So what I've done is I've graphed the original on my calculator. And you see there the line is. Again, there's our vertex of 5, negative 21. And what I've done is I've put in our answer, or our new equation, our new quadratic, written in vertex form. So if we graph that, we have a bigger line here. You'll see that if it overlaps it, we have just rewritten the equation. We haven't changed it at all. It's the same exact line. So there it is. You see that our new equation overlapped the old one, and again, all we've done is write it in a different way. So